And when we look up at the night sky, we're greeted by a vast expanse of twinkling stars. Each point of light represents a distant sun, many similar to our own. But have you ever stopped to consider the sheer distance between us and those celestial objects? The universe is so vast that using miles or kilometers to measure distances becomes incredibly cumbersome. Instead, astronomers rely on two fascinating concepts: light speed and light years. Imagine for a moment that you could travel at the fastest speed possible. That speed, my friends, is the speed of light. It's the ultimate speed limit in the universe, a cosmic rule that governs how information travels. Light from the sun takes about 8 minutes to reach us here on Earth. That means we're seeing the sun as it was 8 minutes ago. The farther out into space we look, the further back in time we're seeing. Our universe is a vast and mysterious place, filled with wonders that continue to amaze us. By understanding the concepts of light speed and light years, we can begin to grasp the incredible distances involved in astronomy and appreciate the true scale of the cosmos. Join me as we delve into the mind-blowing world of light speed and the incredible distances it helps us measure. Light travels at an astonishing speed of approximately 299,792,458 meters per second. That's roughly 186,282 miles per second. To put that into perspective, imagine you could travel around the Earth's equator at the speed of light. You could circle the globe over 7 times in just 1 second. That's unbelievably fast. Nothing in the universe can travel faster than light. It's a fundamental constant in physics. This speed limit has profound implications for our understanding of the universe. It means that there are limits to how quickly we can communicate with distant objects and how far we can travel in space. Consider this. When you turn on a light switch, the room seems to illuminate instantly. But even light takes time to travel. The seemingly instantaneous nature of light is only because its speed is so incredibly fast relative to our everyday experiences. Now let's talk about light years. A light year is the distance that light travels in 1 year. It's not a measure of time, but of distance, and an incredibly vast one at that. To get a sense of how far a light year is, let's do a little math. We know light travels at 186,282 miles per second. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and 365 days in a year. Multiplying all those numbers together, we find that light travels about 5,878,625,370,000 miles in a single year. That's 5.88 trillion miles. That's an incredibly large number. It's hard to even fathom such a distance, but that's the scale we're dealing with when we talk about the universe. The nearest star to our sun, Proxima Centauri, is a little over 4 light years away. That means the light we see from Proxima Centauri tonight left the star over 4 years ago. To really grasp the vastness represented by a single light year, let's imagine taking a trip to Proxima Centauri, our closest stellar neighbor. Now, we don't have spaceships that can travel anywhere near the speed of light. But for this thought experiment, let's imagine we could hop into a jet plane capable of traveling at a constant speed of 600 miles per hour. How long do you think it would take to reach Proxima Centauri at that speed? Buckle up, because the answer is mind-boggling. Remember, Proxima Centauri is a little over 4 light years away, and we just calculated that a single light year is about 5.88 trillion miles. Dividing the total distance, 4 light years times 5.88 trillion miles per light year, by the jet's speed of 600 miles per hour, we find that it would take our hypothetical jet plane approximately 39.2 million years to reach Proxima Centauri. That's right, 39.2 million years. To put that into perspective, that's longer than the reign of the dinosaurs on Earth. It's a journey that would span countless generations. Clearly, even at the impressive speed of a jet plane, traversing the vast distances between stars is an undertaking of unimaginable proportions. Okay, so a jet plane is out of the question. What about a rocket? Surely, with their incredible speed and power, rockets could make the trip to Proxima Centauri in a more reasonable amount of time, right? Well, not quite. The fastest spacecraft ever built by humans, the Parker Solar Probe, can reach speeds of over 430,000 miles per hour. That's incredibly fast, but still a tiny fraction of the speed of light. Even at that incredible speed, it would still take the Parker Solar Probe tens of thousands of years to reach Proxima Centauri. These calculations highlight the incredible challenges we face in exploring even our closest cosmic neighbors. The distances involved are so vast that even our most advanced technology seems woefully inadequate. But these challenges also serve to ignite our imaginations and inspire us to develop new technologies that might one day allow us to journey to the stars. It's clear that using miles or kilometers to discuss distances on a cosmic scale quickly becomes unwieldy. That's why astronomers use light years. The light year is more than just a unit of measurement. It's a reminder of the profound connection between space and time. When we look at a distant galaxy billions of light years away, we're not just seeing a point of light in the sky. We're looking back in time, witnessing that galaxy as it existed billions of years ago. Consider our own galaxy, the Milky Way. It's a barred spiral galaxy about 100,000 light years across. That means it takes light 100,000 years to travel from one side of our galaxy to the other. And the Milky Way is just one of billions of galaxies in the observable universe. The universe is a place of almost incomprehensible scale. But through the lens of light years, we can begin to grasp the vast distances involved and appreciate the interconnectedness of space and time. Here's a fun fact to leave you with. Did you know that the Andromeda Galaxy, our nearest galactic neighbor, is actually on a collision course with the Milky Way? Don't worry though, it's not going to happen for another 4 billion years or so, and when it does happen, it will be less of a collision and more of a cosmic dance, with the two galaxies merging over billions of years to form a single larger galaxy. The Andromeda Galaxy is currently about 2.5 million light years away. That means the light we see from Andromeda tonight left the galaxy about 2.5 million years ago. Think about that for a moment. When that light started its journey towards Earth, our early human ancestors were just beginning to evolve. The universe is a vast and awe-inspiring place. By understanding the concepts of light speed and light years, we can begin to comprehend the incredible distances involved and appreciate the wonders that lie beyond our own planet. So the next time you look up at the night sky, remember that you are looking out into the vast expanse of space and time, witnessing the universe as it was millions, even billions of years ago.